Okay guys, it's good to talk to you again. We're going to do some problem solving today. Let's go ahead and look at our lesson objective. And our lesson objective today is 3.5B. That's to represent and solve 1 and 2 step multiplication and division problems within 100 using arrays, strip diagrams, and equations. And what we want to be able to do by the end of the lesson is I can use models to solve word problems. Let's go ahead and look at this video on two-step word problems. It's a Khan Academy video. These are real good videos. So go ahead and get ready and watch.
Akshay brought 4 boxes of chocolate truffles to a party. Each box contains 6 truffles. Every guest at the party ate exactly 3 truffles, and there were none left over. How many guests must there have been at the party, must have attended the party? So we're trying to figure out how many guests must have attended the party. So let's actually define a letter to represent that. So let's say that P, or let's say G for guests. Let's say that G is equal to the number of guests at the party. Then we could actually set up a relation between the number of guests, the number of truffles each guest ate, and then the total number of chocolates. So what was the total number of chocolates that we have at this party? Well, he bought 4 boxes, and each box contains 6 truffles. So the total number of chocolates at the party must have been 4 times 6. 4 times 6 truffles must have been the total number of truffles at the party. So let me write this down. This is the number of truffles total. Number of truffles total. Now, what's another way of thinking about the total number of truffles at the party? Well, you have G guests. So you have G guests, and each guest ate 3 truffles. Each guest ate 3 truffles. So G times 3 is also going to be the number of truffles at the party. Number of truffles total. Number of truffles total. So these two things need to be equal to each other. So we could figure out what 4 times 6 is, and then we should say, well, 4 times 6 is going to be some number, and G times 3 has to equal that same number. What must G be? So let's think about that step by step. So let's just visualize 4 times 6. So here is 1 box of truffles. We get 6 truffles. So it's 1 times 6, 2 times 6, 3 times 6, and 4 times 6. Or another way of thinking about 4 times 6, that's the same thing as 6 plus 6 plus 6 plus 6, which is 6, 12, 18, 24. So what we have here on the left-hand side is 24. So we get 24. And now we know that this is going to be equal to the number of guests at the party. This is going to be equal to the number of guests at the party times 3. Times 3. So what times 3 is equal to 24? And another way of viewing this is if G times 3 is equal to 24, that means that 24 divided by 3 must be equal to G. Must be equal to G. So one way of thinking about it, if I were to divide these truffles, these 24 truffles, into groups of 3 for each guest, well, the number of groups I'm going to have will tell me the number of guests I have. So let's do that. So let's divide it into groups of 3. So let's see, here is 1 group of 3, right over here, 1 group of 3. And now I have another group of 3, so 2 groups of 3. Now I have 3 groups of 3. 3 groups of 3. Here's 4 groups of 3. Here is 5 groups of 3, 6 groups of 3, 7 groups of 3, and 8 groups of 3. So if I were to take 24 things and divide it into groups of 3, I get 8 groups. So we see that G, let me get my pen tool, we see that G, or I could say 24 divided by 3 is 8. which must be equal to the number of guests at the party. The other way of thinking about it is I'm like, hey, some mystery number here, G, that I'm trying to figure out, the number of guests at the party times 3 is equal to 24. So what times 3 is 24? Well, you could just think about all the multiples of 3. 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 12, 15, 18, 21, 24. That's 3 times 1, 2, 3, 4, 5, 6, 7, 8. 3 times 8 is 24, so G must be equal to 8, or 8 must be equal to G, or we had exactly 8 guests at our party.
Okay, we're going to look at this question here. It says, Tommy and Laura each picked a book from the library. Tommy's book had a total of 24 pages. He read the same number of pages each day. It took Tommy 4 days to read his book. Laura read twice as many pages of her book each day than Tommy. How many pages of her book did Laura read each day? So we'll go ahead and going to go and break this problem down. We're going to use our cube strategy. So that's CUBES. And first thing I'm going to do is I'm going to circle important information. So first thing is circle is there's Tommy's book is a total of 24 total pages. And he read the same number of pages every day. Same number every day. Actually, that's probably going to be a box-in thing. Same number every day. It's going to tell us that there's equal groups. Right here it says it took Tommy 4 days to read his book. So, and Laura read twice as many pages of her book, and that's going to kind of be an operational clue too. So next thing I'm going to do is I'm going to underline the question, make sure I understand what it's asking. And what I need to do is figure out how many pages of her book did Laura read each day. So we're trying to figure out how many pages she read each day. So I'm going to go ahead and box in some operational clues. We already boxed in the same number of pages each day. And right here I said Laura read each day. So that's what we're trying to find out, how many pages she read each day. And over here I got same number each day. So it looks like we have a lot of equal size groups here. So whenever we have equal size groups, it's a good idea to go ahead and we're going to evaluate here. Evaluate. It's good to think about our get strategy. So that's groups. We're going to figure out how many groups there are, how many are in each group, and what the total is. So right here it says total of 24 pages. So I think that's going to be the total. 24 right there. That's pages, and that's of Tommy's book. Pages of Tommy's book. So I'm going to kind of abbreviate PTB. Pages of Tommy's book. So he read the same number each day. And so you read the same number each day. So I think right there, that's what we're trying to find out. Because it took Tommy 4 days to read his book. So the groups are going to be the 4 days. So that looks like that problem to solve right there looks like the operation we're going to use, or how we're going to solve it, would be 24, because we already know what the total is. It wouldn't be a multiplication problem. And 24 divided by 4. So we need to figure out what 24 divided by 4 is. We could go ahead, we could say that we have 4 groups, and what we're trying to do is times something equals 24. That'd be another way of doing it. Okay, but we're going to use an array to solve this. We're going to use an array to figure out how many pages Tommy read each day. So the array would be, I'm going to do, the dots are going to represent pages, and he read over a period of 4 days. So that'd be 1, 2, 3, 4. And we'll keep on going until we get to 24. That'll tell us tell me how many pages he read each day. So I got 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. So that's the total amount of pages that he read right there. And we already went ahead and said that these are the days. That's day 1, day 2, day 3, and day 4. So to figure out how many pages he read each day would be how many each row. So that would be right there. So it looks like he read 1, 2, 3, 4, 5, 6 pages each day. So 24 divided by 4 equals 6, or 4 times 6 equals 24. So that means Tommy read 6 pages each day. Let's go back and look at our question. Does that answer my question? So how many pages of her book did Laura read each day? So that doesn't answer my question. I can't stop right there. If this is a multiple choice question, chances are, I bet 6 would be one of my answer choices. So I haven't solved my question yet. So I need to go back up here and look, and it says right here that Laura read twice as many pages of her book each day. I forgot to box in. So she read 24 pages, or twice as many pages than Tommy read. So if she read twice as many pages, it looks like we're still talking about groups here. So I'm going to say groups, each, and total. So I'm going to guess that the each is going to be 6. That's going to be how many pages Tommy read. And there's 2 groups right there. So I'm trying to figure out the total. So this is what I'm trying to figure out. So whenever I'm talking about equal size groups and I'm trying to figure out what the total is, that sounds like a multiplication problem. So that would be 2 times 6, and we need to figure out what 2 times 6 equals, and that'll tell us how many pages Laura read each day. So I could go ahead and make an array for that. So we'll say Laura's book pages are green. And so we'll do an array right here for Laura. So there's 2 groups. That's 1, 2, and each group has 6 in it. So I already got 1, 2, 3, 4, 5, 6. And then the second group's going to have 6 in it also. So 2 groups of 6. I go ahead and count it. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 2 times 6 does equal 12. Or we could say, if we basically just double 6, if we double 6, we get 12. So that means Laura read 12 pages each day. Laura read 12 pages each day. Okay, we're looking at this problem right here. It says, Carson bought 60 colored marbles. He separated the marbles into 4 equal packages for his children. Okay, each package for each child has the same colors of marbles, and each package of marbles contain 5 marbles of each color. So what we're trying to find out is how many different colors of marbles did Carson buy? So we're going to go ahead and break this problem down using our cube strategy. So C-U-B-E-S. So first thing I'm going to do is I'm going to circle important information. So there's 60 colored marbles. He separated them into 4 equal packages. Okay, each package for his children had the same colors of marbles, and each package of marbles contained 5 marbles of each color. Next thing I'll do is I'll underline the question. It says, how many different colors of marbles did Carson buy? So we try to figure out how many different colors of marbles Carson bought. Go ahead and box in some operational clues. So right here I'll see the packages are equal, so they're equal size groups. And each package for each child, so each package for each child has the same colors of marbles. And right here it says each package of marbles contain 5 marbles of each color. So see each in here a lot. We're definitely talking about equal size groups here. So we'll go ahead and since we're talking about equal size groups, we're going to do some evaluating here. We'll go ahead and talk about the get strategy, just like we always do when we're talking about equal size groups. So we got groups, each, and total. So go ahead and break this problem apart, and I think I'm going to start with first the total. It looks like here he bought 60 marbles, and that's 60 marbles total. So I'm going to put the 60 right here in my total. And he separated the marbles into 4 equal packages for his children. So the packages sounds like that's going to be my group. So there's 4 groups. So what we need to do is figure out how many marbles are in each package. Is my first step. So I got 4, and these are packages. And the 60 are marbles. So whenever I've got equal size groups and I know what the total is, that sounds like a division problem every time. So that'd be 60 divided by 4. Okay, or I could say 4 times something equals 60. So I think I'm going to go ahead and we're going to try and make a strip diagram with this. Okay, we'll make a strip diagram to represent our problem because I know how many groups there are. So I'm going to go ahead and make a strip diagram, and I know what the total is. The total is 60 marbles. And it looks like I have 4 packages, so that's, I'm going to break my strip in half, and I'm going to break each half in half. So to figure out how many marbles are going to go in each group, I'll just go ahead and start separating the marbles. But 60 is a lot. I know that I could probably do at least 10 in each group because that would be 40 if I did 10 in each group. So we're going to start right there. So I'll start with 40, and I'm going to do my X's to represent my 10s. I like my Roman numerals. That's 10, 20, 30, 40. So that still leaves 20 marbles. So I'm pretty sure I could probably get 5 more in each group. So I got 40. So that'd be 45, 50, 55, 60. So I separate all the marbles out, and that looks like the Roman numeral for 15 because I got 10 and 5. So looks like there's going to be 15 in each group. So 60 divided by 4 is 15. So that means he put, so the 15 represents how many marbles are in each package. So this would be package 1, that could be package 2, package 3, and package 4. So 15, does 15 answer my question though? 15 in each package. And the question is, how many different colors of marbles did Carson buy? So that doesn't really answer my question, does it? So I still need to do some work here. So I'm going to go back to my problem here, and we already used that the 4 packages, and we used a total of 40 marbles. But we still see that each package for each child has the same colors of marbles in there, and each package of marbles contains 5 marbles of each color. So we're still got some equal size groups here, so we'll go back to our get strategy. So groups, each, and total right here. So I'm looking at a total, I think, of 15 marbles in each package, right? And right here it says there's 5 marbles of each color. So that's going to be my each. So I got 5 of each color. So I've got to figure out how many groups there are. So whenever I try to figure out how many groups there are, strip diagram wouldn't really work too well for that. So whenever I'm trying to figure out how many groups there are, I think it'd be good to do an array. I like to do arrays for that. So if I'm doing arrays, see, we'll do our fancy, or sometimes our marbles are kind of funny colored like that. So we'll do that. We'll make our marbles like that. And I'll make an array, and it says that each group has 5. So I'll go ahead and make my array to where there's 5 in each group. So that'd be 1, 2, 3, 4, 5. I'm going to keep on going until I get to 15. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I put on my marbles, and it looks like, so my columns are going to represent how many are in each package, and my rows are going to represent the colors. So this would be color 1, this would be color 2, and this would be color 3. So it looks like I got 3 different colors. Or I could have did it like this. I could have went ahead and said that 1, 2, 3, 4, 5 are red. 6, 7, 8, 9, 10 are blue. And 11, 12, 13, 14, 15. I can see I got 3 different colors right there. So that means that there are 3 different groups right there, or 3 different colors. So there's 3 different colors. 3 different colors of marbles. And that does answer my question. Okay, we're going to work on this guided practice problem here. And you'll go follow along as I read. It says 100 third grade students will go on a field trip. 4 equal-sized buses are completely filled. Okay, and 4 students are riding with parents. Which equation can be used to find the number of students riding on each bus? So just so we understand the question better, we're going to go ahead and use our cube strategy like we usually do. And we're going to go ahead and kind of break the problem apart and make sure we understand what it's asking us to do. So first thing we're going to do is we're going to circle the important information. So first thing that's important in the question is there are 100 students, going on a field trip. Okay, next thing I see in the statement is there's 4 equal-sized buses. And the next thing, there are 4 students that are riding with their parents. So that looks like most of the important information that we need to solve the problem. So next thing I'm going to do is make sure I understand what the problem is asking me. So I'm going to underline the question. So the question is, which equation can be used to find the number of students riding on each bus? So if I haven't answered the question, if I haven't figured out how many students are riding on each bus, we're not done yet. So you see we circled a lot of things in the problem. So there's a lot of things we need to do before we get to the answer, I believe. So next thing I'll do is I'm going to box in maybe some clues. It's going to tell me what I need to do. So first thing I see there is equal-sized buses, and they're completely filled. So that's definitely equal-sized groups right there. Okay, and next thing I see is 4 students that are riding with their parents. Okay, that's important in the question. And the last thing I see right here is number of students riding on each bus. So that means each bus is going to have the same number of students riding on it. So see a lot of things that's talking about equal-sized groups there. But we're going to get in the evaluation stage of the question right now. So we're going to evaluate. One thing I like to use when I evaluate is I'm trying to figure out what operation I'm going to use. So I'm going to go ahead and draw my little cross here with my addition, subtraction, multiplication, and division sign right here. And we're going to do some evaluating here. What's the first thing you think we need to find out in order to solve this question? Yep, that's right. We need to figure out how many students are going to be riding the bus on the field trip. Okay, in order to find out how many students are on each bus. So I'm going to look at it real quick here. I've got 100 students in the third grade, so I got 100 students. I have 4 students that are riding with parents, and we're trying to find out how many students are going to be riding the bus. So I see the same label there on every one of the things that we talked about. There is there's 100 students, there's 4 students riding with parents, and trying to figure out how many students are going to be riding buses on the field trip. So whenever my labels are same like that, that kind of lends itself well to addition and subtraction. Okay, we don't see anything in that part of the problem that tells us that we're talking about groups or equal size of anything. It's just students, and students are not riding on the bus, basically. So it sounds like when my labels are the same, that looks like an addition subtraction problem. So next thing I'm going to look at, there's 100 third graders going on the field trip, and I have 4 students that are going to be riding with their parents. So are there going to be more than 100 students riding the bus? You're correct. I do not believe there's more. So I got 2 operations I use to make things smaller, and that is subtraction and division. And you see, I circled subtraction twice. So it looks like I'm going to have to do subtracting in this problem to figure out how many students are going to be riding the bus on the field trip. So I have, there's 100 students in the third grade, or 100 students going on the field trip. And of those 100, I have 4 that are riding with their parents. So it sounds like a subtraction problem. What is 100 minus 4? Okay, well, let's check and see. You can see right here, I've got a 4 on the bottom and a 0 on top, so I got more on the floor. So that rhyme tells me go next door. I don't have anything next door, so that means I'm going to have to go all the way over the hundreds place, and I'm going to have to take one of my hundreds, and that's going to leave 0 hundreds, and that will give me 10 tens, because 100 is 10 tens. Now I can take one of my tens, that will leave 9 tens, and one of my tens will give me 10 ones. Now I can subtract. So 4 from 10, I always like to count up, so that's 4, 5, 6, 7, 8, 9, 10. So it looks like 6. So 10 minus 4 is 6. And then in the tens place, all I need to do is bring the 9 down because I'm not taking anything away in the tens place. So it looks like there are 96 students riding the bus. So 96 students riding the bus. Does that tell me how many students are riding each bus? That's correct. It does not tell me how many students are riding each bus. So I need to do some more steps here. So the next thing, we use the 100 students, and we talked about the 4 students that are riding with their parents. I still have 4 equal-sized buses, and I need to figure out how many students are riding on each bus. So that sounds like a grouping, equal-sized groups. So I'm going to use my get strategy right here. So G, E, and T. So do I know how many groups there are? That is correct. There are 4 groups. The 4 groups are the 4 buses. Okay, do you know how many are in each group? That's correct. I do not know how much are in each group, because right down here in the question, it's asking me how many are in each group, how many are in each bus. So I'm trying to find that out. So I'm going to put a question mark under the E. And those are number of students. Okay, and do I know the total? Yes, I do know the total. We figured it out right here. There are 96 students total riding the bus on the field trip. So whenever I'm talking about equal groups and I know the total, that automatically tells me it's going to be a division problem. So the division problem that I'm going to solve is 96 divided by 4. And we can do the related multiplication fact to that. That would be 4 groups of something equals 96. Okay, I know my 4s pretty well. Okay, but that's a relatively high number because 4 times 10 is 40, and that's still not even halfway to 96. So I'm going to have to use some strategies here. So I'm going to go ahead and do a solving part of the division problem here. And what I did is I drew, made a little model over here, a picture of my school here, and I got a picture of the buses here in front of it. So these are the buses getting ready to go on the field trip. And we're going to take those 96 students, because we have 4 students that are riding with parents, so we're not going to count those. So I can go ahead and use my, since I'm trying to find out how many are in each group, I'll just go ahead and start putting the students on the buses. And since 96 is a pretty large number, we already said that 4 times 10 is 40, so it's going to be a pretty large number. So I'm going to start putting 10 students on the bus, and I'm going to go ahead and make X's for the 10s, so that because the X model's 10 in Roman numerals, so we're going to do that. So that's 10, 20, 30, 40. Okay, and we said that 40 is not even halfway 96, so I can put another 10 on the bus. So I'll put the next 10 students on the bus. So that's 50, 60, 70, and 80. So I'm getting kind of close now. So I'm going to go down to 5 since I'm at 80. I'm basically only got 16 more seats left, or 16 more students to put on the bus. So I'm going to start putting them in there by ones. So I'm at 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, and 96. So I have all the students on the bus, and now I can go and figure out how many students I have on each bus. I have 2 groups of 10, which is 20, and a group of 4. So it looks like 24 students are going to be on each bus. So I can go back and solve that 96 divided by 4 equals 24. So there's another way to do it, doing the solving this too. So 24, or 4 times 24 equals 96. So I'm pretty sure there's going to be 24 students on each bus. I'll show you another way to solve that problem though too. We'll go ahead. And since since 96 is really close to 100, if I went ahead and thought about the 100 students, and I want to divide the 100 students onto 4 buses equally, that's a relatively easy math fact because we can relate that to money. We could go ahead and say that that there's 4 quarters in $1, and a quarter is 25. So we could say if we went ahead and said there's going to be 25 on each bus, and then we go ahead and take away the 4 students that are riding. So that's basically taking away 1 from each bus. So that would be minus 1 equals 24. That's just another way of solving that problem the same way. But got one other thing we're going to look at. We're going to look at a strip diagram. Okay, and this is kind of a strip diagram of the problem. So if I'm filling in this strip diagram, I could go ahead and say we start off with 100 students going on a field trip. And I know there's 4 that's going to be riding with parents. So to fill in this block right here, the part that we didn't know, that would be 100 minus 4 equals 96, and that's 96 students riding the bus. Okay, and now I know I have 4 equal buses, so that would be, we went ahead and we figured there's, if we divided 100, which is really close to 96 by 4, that's 25. If I took away 1 from each one of those, that'd be 24. So there's 24 students on each bus. And this would be an example of a strip diagram, a model for solving that problem up there. So we know there's going to be 24 students on each bus. And let's go look back up at our question and make sure we've answered it. And the question is, which equation can be used to find the number of students riding on each bus? So the first one right there, A, 100 minus 4, and then we took the difference and divided that by 4 and got 24. So that looks like the way we would probably solve it. We're going to look at the other ones. Answer choice B. What does answer choice B tell us? That's right. Answer choice B just tells us the students that are going to be riding the bus. It doesn't tell the students that are going to be on each bus. So that's not right. Answer choice C. What does answer choice C tell us? That's right. If we didn't take into consideration the students that were riding with the parents, that would be correct. That if we took all 100 and all 100 students were riding the bus, and we divided by 4, there would be 25 students on each bus. Okay, but we had 4 students that are riding with parents. Answer choice D. How could we have got answer choice D as an answer? Okay, maybe if we didn't read the question carefully and we was up here and we said 4 students are riding with parents, maybe if we misunderstood that and said 4 parents are riding on the bus with the students, that would be, we would go ahead and add 4 to 100, and then we would end up with 104, and 104 divided by 4 equals 26. So, but that is not correct. So A is a correct answer, or the correct equation for how many students are going to be riding on each bus. Okay, it's time to do your independent practice now. There's going to be a blue puzzle piece after this video, and I'll do a PDF in there in between the blue puzzle piece if you'd like to go ahead and print that out to work these problems out. It makes sense to do that if you have the capability of printing out. At least maybe look at the worksheet, the PDF version of it. It might give you a little better idea on how to work it out. But once you go ahead and use the pencil and paper, make sure you go ahead and do the blue puzzle piece, because that's how we check your work. And if you have any questions, just as always, email your teacher or send them a message on Schoology. No matter what, if you don't understand a concept or you're having trouble with any of the videos or anything like that, maybe not working the way you think they should, please contact your teacher and we'll get back to you as soon as we can. Best of luck to you. Take your time and do your very best.